In this section, we'll go through the introduction to the machine learning. The root idea behind this is like an artificial intelligence which enables the system to perform intelligent tasks through the set of rules. That is the major stream of this particular field. Within that, there is a sub branch called machine learning, which is a process of learning from the data without using the complex rules, which involves the training a model from the data sets and predicting the outcomes. Generally, the machine learning comes under the umbrella of AI. It's a sub branch of AI. And furthermore, when we apply deep neural networks to the machine learning, then ML at a larger scale gives us a deep learning with the involvement of artificial neural networks, or deep neural networks such as CNN and etc. So there are three major branches. First one is AI. Under that, a sub branch which is called machine learning, and furthermore, a sub branch of machine learning which is called a deep learning. And artificial intelligence, that is kind of an approach which enables computers to perform the intelligent tasks, right? Where computers are able to mimic the human behavior and perform some sort of intelligent tasks. Whereas machine learning, it approaches to learn underlying pattern in the given data, or in the given features without being explicitly programmed, explicitly programmed. Right? There are several subtypes of types of machine learning, such as supervised machine learning, unsupervised machine learning, semi-supervised machine learning, reinforcement learning, etc. Whereas deep learning approaches, that it is able to learn. Generally, it is expected to learn the underlying representations and patterns in the given set of raw data without being explicitly programmed, with an involvement of the neural networks, such as, let's say, deep neural networks will be used. Deep layers of neural networks will be used, such as the examples are convolutional neural network, recurrent neural network, generative adversarial network, etc. Right? So these are the three major branches which we used to use. Artificial intelligence, in that the intelligence, that means what, experiencing or ability to learn and understand and use it for deciding the future course or maybe future prediction. That's what we are going to understand. And AI, generally, it enables the machine to do the intelligent tasks mimicking the human behavior, right? In different tasks, such as, let's say, problem solving, a discovery of particular conclusion or particular pattern, or maybe particular an outcome, or learning process, dealing with uncertainties, or there are different categories of AI, such as, let's say, problem solving using the search methods, state space search or heuristic search, randomized search, or there are some sort of search based on particular set of rules, right? So there are a few more types of AI, few more categories of AI, which we may touch upon if time permits. Machine learning, with more and more, as we have more and more data available these days, because the information is easily available, task of automatic discovery and learning of the patterns, they are important, and generally this is handled by the machine learning. And there is not much focus on the feature in for machine learning. There is not much focus on the feature extraction or signal processing, but it's not required as a prerequisite. uh, but more emphasis would be on discovery and learning of the patterns by the machine, right? It generally gives the ability to extract the patterns or from the features or given data set. It's treated as pattern learning, for more like associated with the function learning kind of thing. It's such as, let's say, my input data set is X, and maybe with some sort of features or labeled data which we can give if it is a supervised machine learning. So let's say my input data set is X and predicted output is Y, and there is a function which function will try to map the input to the predicted output. That's the basic job of the machine learning. So let's say, based on the input given data, my function tries to map the input to the output and predict a particular output for a given input data. So that's the job of the machine learning. And the goal is generally that function maps my X into Y. That means it will try to predict a particular output Y for a given data set input, for an input given data set to the machine. Whereas if I look at the deep learning, the the task of learning for both the feature representation and also extract the pattern. In machine learning, we weren't extracting we weren't, I mean, learning the features were given along with the along, in the model itself, whereas in deep learning this feature extraction is happening completely by the deep neural network, such as CNN, whereas in machine learning this feature representation part is manual. It'll try to mimic the human way of learning, and it generally learns from the experiences. Based on the current experience, it will store the experience, and then it will try to apply that experience in future, and it will try to extract the outcome. Based on those experiences, it will learn and try to improve the future outcome. Based on those experiences, it will learn and try to predict the future outcome. We need not to specify everything in the beginning here. That's the advantage of the deep learning, because if you have to specify everything to the model, once we have the diagrams and other things, it will be cleared. If you have to specify everything in the beginning, then it's a tedious job, and we don't want to do that. So we need not to specify everything in the beginning. It'll understand so automatically based on the experiences. There are a few more bullets. So generally, it is used when we wanted to learn the complicated concepts, right? We wanted to learning the complicated concept out of the simpler ones. So that based on the simple experiences, we try to learn the complex concepts. What is machine learning? Machine learning says that it is an ability of the computers to learn without being explicitly programmed. Explicitly programmed means we need not to program our models, because it's a job of that model to generate the program, or through the algorithm it will apply it and try to understand it. Such as, let's say, an example of preparing for the exam, right? Preparing for the exam. Okay, so what we do is generally students, they will feed their brain, or when learning they'll try to read the material. They'll try to look at the questions and what could be the probable answer, and then they will try to prepare. They'll try to go through the notes or slides, online video lectures, quizzes, or previous year question papers, etc. And they will try to learn that this would be the question, and then this would be the outcome, right? This would be the question, and this would be the outcome before the exam. So they're trying to train their brain with the input as well as the output. They'll try to look at that this could be the question, this would be the output, this would be the answer, right? And then they'll try to apply that logic to solve those kind of questions when they actually come in the exam. Similarly, machine learning model, right? In machine learning, we train the machine with data such as inputs and outputs. Both of them are given to the model, and when the time comes during the test on the data, we give only inputs. Such as, let's say, when the exam comes, we give only questions. But based on your previous training, you will try to extract the answers which you have feed in your mind when reading or preparing for the exams, right? And then try to produce the outcomes, right? So, and then it will try to achieve the outcome based on your preparation. That's the general idea of the machine learning. How machine learning works? Machine learning, where the system learns from the historical data. So you give the past data input, and it will try to build the prediction models, right? And then also sometimes if it is a supervised, sometimes we give the label data. If it is unsupervised, we do not give the label data, right? We give the inputs, and then It will try to build the prediction models, and whenever it receives new data based on the previous input data sets, it will try to identify the patterns, or maybe it will try to map along with the features, and then it will try to predict the output from it. And then it will try to predict the output from it, right? For the new given data. For the new given data. So generally we give the past input data to the machine learning algorithm. This machine learning algorithm or a program will learn from the past data set. They'll build the logical models in terms of training. And when new data is given, it gives the output. Such as, let's say, during the exam, we are preparing, our mind will try to prepare that or build the logic and train the model so that during the exam, when a question comes, we try to produce the outcome based on our previous training, based on our previous training. There are several features of machine learning, such as machine learning uses the data to detect the various patterns in the given data set. It can learn from the past data and improve automatically. It is a data-driven technology, and generally machine learning is like a data mining, and it is also dealing with vast data sometimes, right? Very large amount of data sets can be given to the algorithm. Why we use machine learning, or where we use machine learning? Because since it has a capability of learning without being explicitly programmed, there are multiple applications where many tasks can be done, such as, let's say, object recognition, where we wanted to identify a particular object, such as, let's say, different types of fruits are given. We try to segregate those, that's an apple or maybe strawberry or something else. When we wanted to find out the summary of certain things, right? Then also we can do prediction tasks can be done. Classification is also possible, such as, let's say, 1-0 sort of thing, or maybe whether the person has a cancer or not. Different clustering, this is kind of a pattern identification where different behaviors can be grouped into the clusters, and then we can predict the outcome. Recommender systems, such as, let's say, it will try to recommend different items based on our past spending behaviors. And there are many more applications. There are many more applications of machine learning which can be extended in terms of deep learning also. There is a difference between traditional programming and machine learning. The basic difference between the traditional programming and machine learning is, in traditional programming, we give the data inputs and we write the program and we give it to the machine, right? It will consume the data and give us the output using that program, what we have written. So we have to write the program here. We feed the data and program and run it on a machine to get the output, and run it on a machine to get the output. Whereas in machine learning, we feed data, input, and output, right? Such as, let's say, preparing for the exam. So we give a mind a question and the answer, a question and the answer, a question and the answer. So like our mind would prepare for it, right? So we do not write the, or do not give the program as an input to the machine. So machine, that's the major advantage of machine learning. Complex programming would be taken care of by the machine itself, right? And when the real input is given, when the output is not known, then based on the previous input and output experiences, machine will try to produce my outcome. And generally the program is also generated by the model during the training process, right? And what does exactly learning means for the computer, such as, let's say, learning from the experiences with reference to or with respect to some class of tasks. If its performance in a given task, let's say, improve the experience, such as, let's say, as we have said, if I'm doing a particular task and if I get a reward as an outcome, I store it as an experience and I'll continue doing in that particular direction. On the contrary, if I'm doing a particular task and if I get a penalty, or if I do not get any reward, I will stop going in that particular direction and try to tune in other direction and try to accomplish higher reward in the next one. Such as, let's say, learn from the experience E with reference to some class of task T and performance measure P. If the performance at that particular task T is higher, then it will improve my experience, correct? Some such as, let's say, reward is higher, then it will say that's a good experience, we should continue in that particular direction. There are several applications of machine learning, such as, let's say, automatic language translation, medical diagnose medical diagnosis, stock market predictions, fraud detections. There are many email spam detections, self-driving car, product recommendations on e-commerce, these online sites where we used to do the shopping, traffic prediction, speech recognition, image recognition, etc. These are the major applications of the machine learning. These are the major applications of the machine learning. There is a difference between machine learning and deep learning. A specific difference between machine learning and deep learning, let's say, such as, let's say, the upper one of the image is part A is the machine learning. Well, say, let's say we are giving the input images such as, let's say, car or bus, scooter, etc., and we have to do the manual feature extractions such as, let's say, we can give the dimension of a car, let's say a few meters long. Bus could be a bit more longer than the car, and scooter could be a smaller version, right? So this length can be taken as a feature, and that we have to manually extract it and give it to the classification algorithm based on the input data. And given the features, classification algorithm will try to segregate them into different classes, such as, let's say, class 1 belongs to cars, class 2 belongs to buses, class 3 belongs to scooters, right? And then when we give new input, it will segregate them into different classes and predict the outcome or predict the output, that this would be a skewed scooter, this input image is a car, or this input image is a bus. Whereas in deep learning, this feature extraction and classification part is automated using deep neural networks, such as, let's say, application of CNN, convolutional neural network. So this feature extraction, it will try to extract the feature from the image itself, and then it will try to segregate them into different classes, that this was car, this was a scooter, this was a bus, right? So this is automated using deep learning. Whereas application of deep number of neural network layers is again a unique feature of my deep learning, such as, let's say, we use in CNN. That's the major difference between machine learning and deep learning. What's the difference between neural network and deep learning? The concept of deep learning was first originated from the neural network. Like, such as a good example of deep neural network is like feed forward neural network that we will see. Generally, back propagation is a workhorse algorithm for learning the parameters of feed forward neural network. A back propagation did not work well for the networks having more than a smaller number of having more than a smaller number of hidden layers. Sometimes insufficient data will lead us towards the overfitting and difficulty in training. These are some of the difficulties with the model. The major difference between neural network and deep learning is, in neural network, you can see the number of layers or number of hidden layers are lesser, whereas in deep learning, number of neural networks layers are many, right, which are used for feature extractions and predictions. Here the links, they carry the signals from one node to another node, boosting the damping of them according to the weights and biases, right? So it'll for each for going from each node to the next node of the next layer, it will try to adjust my weights and those link weights, and it will try to fire up a particular relevant neural network nodes, and it will try to output uh, the given input, right? So for it will try to predict the output for a given input, such as, let's say, that particular image belongs to a particular person, that would be predicted here, that's the person, based on my training. That's the major difference. So here the number of layers are more in deep learning compared to the NN, right? That's my major difference between neural networks and deep learning. Now, if I say some of the people, they used to classify into four sub branches, such as, let's say, AI is a larger umbrella, which try to simulate the imitation of the human intelligence in the machine, which is considered as AI. Programming machines to mimic the human behaviors, such as like thinking, learning, problem solving. These are the major tasks of AI. Where furthermore, the ML is the methodology of training the system to be able to learn from the past data to make the accurate decisions and predictions. That's done by the machine learning. A sub branch between deep learning and machine learning is introduced at artificial neural networks, where the ML systems, they are inspired by the human brain neural networks, and they consist of the neurons. They are connected in one layer to learn the relationships between inputs and outputs. Whereas deep learning, which generally deep learning engages the large number of neural networks with multiple layers to extract the higher level of input features to give a good representation between input and output, right? So this could also be a possibility. This is how also people used to represent AI. Then the sub branch of AI is machine learning. Then ANN comes as a sub branch further of ML, and finally the deep learning, which is again a sub branch of artificial neural network. That's how these people used to present. That's the basic idea. There are several applications, such as, let's say, AI is generally used in natural language processing, visual perception, automatic programming, intelligent robot, and then machine learning. There are multiple algorithms, such as, let's say, linear slash logistic regression, k-means, support vector machine, principal component analysis, random forest, k nearest neighbor, uh, decision tree, so on. In neural networks, some of the examples are such as, let's say, Boltzmann neural network, MLP. In deep learning, we used to go with CNN, RNN, GAN, or DPN. We'll explore them one by one in subsequent sessions.